All right, we're gonna get started. Everyone, so grab a seat. Thank you, everyone, for coming. I'm very happy to see so many of you at this event. I'm Yukfei Chan, one of the co-leaders of OWASP Toronto. I am here with the team of co-leaders. We've got Ads, who will introduce himself later. We've got Adam, and we've got Ignatius, who works at Deep Cove and who is hosting us, and we've got Ophil here as well. First, I'd like to thank Deep Cove Cybersecurity for hosting us, providing the venue, and also for sponsoring the pizza. And I would like to invite Mike to say a few words.
Everyone, thanks for coming. I'm Mike Crocker, founder of Deep Cove Cyber. Great to see you all here interested in AI and cybersecurity and the implications of that. I know you've been a member of the OWASP team for quite a while, so excited to have you here and hosting tonight. So welcome and enjoy.
Thank you.
Chat after if you have any questions about what we are and what we do.
Thanks. So a few housekeeping items. If you would like to use the washrooms, they are outside, and then you turn right. The ladies is to the left, and then the gentleman is to the right. After that, if you need any CP credits for attending this session, come to us with one of your forms, and we'll happily sign it. But if you don't do that, we won't be able to verify that you were here. Afterwards, is anyone hiring here? Raise your hand. I'm also hiring. Is anyone looking for a job? Okay, awesome. So maybe during a break or after the talk, when we'll do some networking, come talk to us about the role. And I think gentleman here from Jared. Yeah. Happy to talk to people who would be.
He's
candidates.
pretty good.
Other than that, I think that's it for me. If you have any questions about OWASP, feel free to reach out to us. It's on Meetup, on social media, or on our chapter page on OWASP. And then, other than that, I'll pass it over to Ads.
Thank you, everyone. So a bit of a disclosure, I kind of like semi-prepped, and I was going to have like some speaker notes, and then I kind of like the sharing deal. I'm just going to like shoot from the hip. So anyway, I'm going to do like a mix of demo stuff, and also like, cause I don't want to kill you guys with slide decks. Any questions, please feel free to interrupt. But probably maybe just try and get through like the meat of stuff, and then if you have any questions, and like, or also feel free to like ping me after the event or social media or whatever, right? So yeah, my name's Ads. I'm a AI security researcher at Dreadnode. Our mission is advancing the offensive capability of machine learning. So we're very much at the fork of machine learning and security. Let me just. Yeah, so a bit about me. So predominantly where I started, I actually started out as a network intern. I found breaking things much more fun than building things, so that's kind of how I got into network pen testing. And from there, I kind of went into like web apps, doing a lot of bug bounty stuff. I used to work for a frontier model company, which is where I kind of got like really involved into like red teaming AI, as well as like traditional blue team ML SecOps for protecting like the machine learning development lifecycle. So kind of like I kind of sit at the fork between like the software SDLC and the machine learning lifecycle. I'm also part of the OWASP Toronto crew. Thank you everyone for putting together today's event, and also to Deep Cove. And I also lead the OWASP Top 10 for LLM Applications with Emmanuel, who's over there. So yeah. Tonight's rundown, just a brief intro. I'll try like make my slides available if anyone's interested. But I mean, yeah. So the first thing's like with like it the sheer like velocity of AI. Every man and his dog is like putting like AI into their product. I'm like really overwhelmed, and thank you guys for all coming out tonight, because like this is like a really big turnout, and I'm sure AI was probably something to do with it. But yeah, this is like a totally new space, right? So we have a lot more execution primitives than we did before. You know, we have like things like multi-chain attacks where we can get like prompt injection to remote code execution or SQL injection or SRF. We have deserialization vulnerabilities, memory corruption bugs. Traditionally, like ML or machine learning or AI or however you want to term this, is a lot of it has been like academic and research based. So a lot of these like security concepts and fundamentals, which we're used to or we seem to have been doing in traditional security pipelines, are not being done right now, right? And kind of as this like industry and this space is maturing, there's a lot of new growth for that, but there's also a lot of like shiny rocks. So the first thing I'm going to talk about, I'm going to like kind of do like blue team, then a bit more like agents and red teaming. But one thing is machine learning model registries. So like everyone has the like ability to download a model of Hugging Face now, right? I'm sure everyone's heard of Hugging Face, which is like a very popular model registry where you can, I think it has over about 1.5 million models right now, where you can like load a model. Let's say you want to like fine tune Llama, right? So you can literally like run it on your own hardware. One thing with machine learning models, they do inherit a lot of deserialization vulnerabilities. A lot of them are in like pickle format, which is extremely dangerous. The idea is that obviously I could like put like something like remote arbitrary code execution into a model file, send it to someone, they like host it on their infrastructure, load it, and then pop like a backdoor or something, right? So the first tool I'm going to talk about is called Dyana, which is just like a take on dynamic analysis. Sorry, the slide's a bit fuzzy, but the idea of where we started, like traditionally, it's kind of cool because we're actually an offensive AI company and we're not like defensive. But like myself and a colleague, when we started working on this, we were really interested to know like what happens when you load one of these models for Hugging Face, right? So it's kind of fuzzy, but you can see there's like a bunch of like safe sensors files. There's a bunch of files. These are all like components of software, which is kind of crazy how many people are just kind of like, without verifying it, are just kind of running it on their things. So traditional sandboxes won't work because we actually need to actually load the model, as in like we need to be able to run inference on it. It's not just like uploading something to a sandbox. And a lot of like current tooling only scans things like pickle files. There's a lot of other kind of machine learning files like Onyx and stuff like that. So we were really interested in like profiling models, but then a kind of curiosity in the way that we architected the tool kind of like got us into doing other parts of it. So you can think of it almost like a kind of like an ML bomb, if anyone's like familiar with S-bomb. Very kind of similar, right? So yeah, so sorry, actually, good point. So when we actually started out, we actually identified like as an easy way of like backdooring any model that's hosted on Hugging Face as well, which I'll just demonstrate in this code here. But effectively, you can see on the left-hand side, it's just in like a JSON config file, and I've like just put like a very trivial like Python script in the back, which is just like cat etc password, right? So I put some slides in, but I'm going to do like a bit of a really quick live demo. So Dyana is available on PyPy. It's a Python tool we create, so you can just do like pip install Dyana. And where is it? Cool. So what I'm kind of showing you here, sorry, I'm bad at multitasking, and I hope everyone can hear me. But on the left-hand side, what we're actually doing is we're using a tool called Tracy, if anyone's familiar, which uses eBPF and raises security events based on like detections, network movement, sensitive file structures, things like that. And we're using we're using Tracy under the hood. So we wanted to get something as close as possible, which is like eBPF is like very transparent and gives you great abstractions that way. So on the left-hand side, just run a simple trace of Dyana running Llama 3.21b. You can see here we get like a bunch of information. Every time you run a trace, actually you get like a massive trace.json file, which is a structured log output, which you can like send or something to like a seam, which you could use then like look at detections, events. So like it gives you some basic profiling information. But the main thing that I want to highlight here is on the right-hand side, just using like this trivial backdoor I put in here. When we're actually like profiling the model here, you can see like these requests to malicious.com and cat.etc passwords. So the idea is like it's very simple for someone to backdoor a model, like exfiltrate data off your machine, right? The great thing about Dyana, like I said as well, is if you do so there's a bunch also, yeah, so it's a very big file. But this will give you so much information that you can even get down to like Python process IDs, other flags, stuff like that. So there's a bunch of like interesting information which you could use to. Oh yeah, of course, yeah. Sorry, is that better? Yeah, no worries. Anyway, so yeah. We also, in Dyana, we also have a concept of what's called loaders. A loader is, so the idea is like our base loader is auto model, which is the default Hugging Face library. So by theoretically, like as long as you have the hardware available to run the model, then you can actually profile any model of Hugging Face using this tool. We also have like loaders for pickle, which are like pickle files. So again here, let me just actually kill this now, so hopefully it's a bit bigger. So I just created like a malicious pickle file as well. And like I say, we can get similar kind of output here. We can see that this is actually like printing cat.etc password. Of course, obviously this is all this like benign data for this demo. But yeah, like Dyana will load and profile the file that's to be loaded in a sandbox environment. The Docker container is automatically removed after each execution. So this is like completely sandboxed and gives you like a great way to profile models. We also have a Selenium loader as well, which effectively will emulate. So what I'm doing here is like I'm just emulating if I use like a Chrome headless browser and go to hattricks.xyz, just like a random website that I chose. And you're able to get like information about the Chrome headless browser. My machine is kind of dying of disk space. This might take a while, but by default as well, we also do like additional sandboxing techniques. So like allow network is disabled by default, but you can allow that. So if you observe some kind of like malicious behavior from like a backdoored file or supply chain, like we have like npm and pip and stuff like that, and if you can disallow the network by default. If you something deemed a backdoor, then you could like allow the network and you get information on like IOCs and IP addresses, which you could do like further details and stuff like that. So like, yeah, example, what I'm showing you here is what happens when you effectively run a Chrome browser that goes to like this website. You can see like all the Chromium processes under the hood that ran, as well as obviously DNS information. File access and top level imports as well. So every time you like run that. So kind of like moving on, I'll talk a bit more like adversarial and like offensive. So like as security people, we're very used to like taking a piece of technology and turning it into a capability. The point of academically interesting to operationally useful, like I said, a lot of this space is based off like academic research, but a lot of it is based on context. So like what is operationally useful versus like what is intent. Defense, again, obviously has much to gain from offensive research, and effectively will end up at the same structure. We're seeing a lot of common tools like LLM firewalls and things like that, very common to the similar patterns that we're actually using in traditional security right now. So kind of talking about agents, I'd say like my most favored definition of an agent is actually if you go to Wikipedia, which is basically an agent is anything that can perceive its environment and act upon that environment. It's a system that uses an LM as an engine and has access to functions called tools. There's some great write-up from like Anthropic and people like that on building effective agents. But like the prevailing option that the models aren't really capable, but like from our research, we can see it where they definitely are when given like individual isolated tasks and clear steps.
Oh, sorry. Just back one slide. You said academically interesting does not equal operationally useful. Is this kind of like what what academic area is this? Is this like for example like auto prompt extraction? Or is it like,
I mean, like so with like auto prompt extraction, like system prompt leakage is like what I mean by that is that this was like that was a while ago was like deemed like a big vulnerability, like relieving the system prompt was like therefore gave you some kind of edge on like how to jailbreak it, which is kind of relevant, but at the same time like now you'll find that every single developer is like released that and even allows an override. So when I mean like operationally relevant, it's just like it's basically just like context, the same as you would do like a traditional like.
Okay, so there's no use in protecting your system prompt, like structurally that is like not going to be defensible ground. Is that kind of your?
I guess like if it was me, so like just taking like like a very simple example, if you have something like ChatGPT where like like the OpenAI wrapper like allows you to override the system prompt, then absolutely like I don't see any relevance in that. However, if you're using like a fine-tuned model and you're hosting it on like a private doctor's website or something like that, then that's where it might be more like contextually relevant. What I guess I mean it like comes down to like almost like threat modeling.
Right.
Does that make sense?
Yeah, kind of, yeah. I guess the other. Sorry, you know what? Just we have to chat.
Yeah, we can chat afterwards. Cool.
Yeah, just the answers are from B2 Dreadnode. Can we detect poison training data or HTTP under poison training data?
With Dyana, sorry, or just adversarial? Oh, with Dyana, no. Dyana is like is loading at runtime. So when I was actually running Dyana here, you'll see the input I'm actually putting is just like, this is a friendly llama. That's actually like the inference request that I'm making. So like the same kind of thing as literally when you like type a message to ChatGPT almost. So training data, data poisoning is like a very relevant thing. I'd say this is more towards like model poisoning, because you're effectively like loading the model of like what it would have at runtime. Data poisoning is more like, I guess, a long-term thing. There's been a lot of research about like backdoors of certain words will like trigger a certain like code execution or something.
So like training data poisoning?
Data poisoning, training data poisoning is kind of very similar. Like training data, you're just referring to like a point in data collection. But it's all relevant.
I mean, obviously super. So actually, he kind of asked a question that I was supposed to ask. So maybe I'll just take the chance of, like, do you kind of have like a ballpark figure for like, because like I think the latest Llama release was trained on something like 1 trillion tokens, right? Like, what kind of what percentage of that total training set would have to be adversarial in order for like adversarial effects to be actually like encoded into like the final model? Like you kind of have like.
It's a really good question. I don't have like any figures per se, but what I can tell you is I can send you the paper afterwards. But there's a paper, poisoning web scale data sets is practical. I can get you the title. It's written by Carlini, Will Pierce, and a few others. But yeah, it just shows how easy it is for someone to like change a page on Wikipedia at a certain time. If you look like let me, there's some kind of like there was one about Charlie Sheen.
It's like you change like one pixel of like an image and it just classifies it like like panda or sure.
Well, yeah, I mean that's like slightly different. Sorry, I'm kind of digressing, going on pictures of Charlie Sheen, but there's a very similar thing. I don't know, like someone edited the Wikipedia page of Charlie Sheen and like turned it into a bar of soap or something, and then like obviously if like Common Crawl was like crawled at that specific time, and then if it's into the model, realistically it is possible. Obviously, it depends. Like it's a very like a long-term effect. Unfortunately, I don't have any like statistics. But yeah.
I think related to that is also like LLM SEO, but that's like
yeah. So yeah, there's a big middle ground between being useless and both autonomous, and there's like a lot of engineering and scaffolding that goes into the process of making like getting the agent to do the thing properly, right? Ideally, we should be using like a workflow or a DAG and push it through the model through a pipeline numerous times. Again, obviously, you're like running it multiple times because you're increasing redundancy to reduce like stochasticity that is produced from like large language models, right? So I had some notes here, but so I kind of introduced our open source LLM wrapper, which is called Rigging. It's a really flexible LLM agent library, featuring stuff like structured input output, tool calling. It has like both the concept of like API and native tooling, batching. It actually also uses XML underneath as well. We use XML tags because it can flow freely in semi-structured text. You'll find that a lot of other LLM wrappers actually use JSON. Models aren't actually used to JSON and require a lot of escaping. And when you use JSON, the whole data has to be JSON, and it's extremely messy. So you get like a really nice clean XML input, which you can use for like numerous system prompts and stuff, right? So again, a function, aka a tool, essential in agentic workflows. Without tools, agents lack the ability to perform actions within an environment and effectively makes them efficient and scalable. Now, I did have a tool here as well. One thing as well, that Rigging actually has a concept of tracing. It uses the OTel open telemetry standard, and it allows integration. I'll do like a quick demo in a second, but effectively you can get like really close to the inference layer when actually running Rigging. So let's go through a demo with Bandit. Has anyone heard of Bandit? Yeah. Bandit is like an SH over the wire CTF. Cool. So let me just make this bigger. So what I'm showing you here is like totally open source. We have like an examples directory in our Rigging GitHub repo link, and you can run like a bunch of examples of LLMs interacting with stuff, right? What I'm going to do show you here is Bandit, which is just like an SH over the wire CTF. So there's an idea of like challenges, and you have like 0 to 20, and you like log into challenge 1. You're able to like basically capture the flag. You get the password for level 2 and so forth, right? So tell you what, let me just clear this to make it a bit. Cool. It runs here. So effectively, all you need to do is like plug in an API key for this to work. It's really simple. And again, this is not just like show you how to get like an agent to interact with a CTF. Oh, gee, sorry, my bad. Cool. So I'm going to start off on level 0 with a password of bandit0. That's like not. It's like you get given a password because you have to have a password for the initial level, right? So you can see here that the agent is actually connecting to the bandit over the wire. Starts level 0. And effectively, what we should be doing is if I load up Logfire. Actually, 1 second. It's kind of quick. I apologize. But kind of like going through, like we can see this like this really nice XML tag structured output here. We can go through the code or whatever. Like I say, all this again is open source, but let me kind of start from the top. So the model is given like a system prompt here, so we can see like our current goals. I'm sorry guys for like the scrolling. It's very difficult to show this on a thing, but we can see the prompt here that's given to the model. It's given basic Unix utilities via an SSH via a shell. It's given actions and it's given a task, right? So through here, we can see the guidance, you can see the model output, and then we get like a full trace of like what the model is like seeing on the box. All this is like fed, like structured, like data in and data out to the model. Obviously, the model looks for a file. All this is fairly self-explanatory. You can see the models like reasoning output here. Again, we have a lot of output, and I'm kind of really doing like demo gods here as well. There we go. So I was able to find the password. And effectively, it'll just like keep enumerating and get to a certain level in the code. We just have like a structure of like how many turns it's able to get, or like how many steps, and then obviously eventually just gives up. But that's like a very simple example of like using rigging to like solve a CTF challenge. I should have. Let's see. As well, rigging uses light LLM under the hood, so you have access to like a ton of models. It's really well like parsed out. So if you actually use a model, like you literally just pass it a database identifier string, so it's super easy to like switch between like Claude or GPT or whatever you wish. I think in this one here we're using GPT-4. So when you're actually like, this is obviously like the main function in here, but effectively like it's literally as simple as just like specifying this model, throwing in like an OpenAI API key, and like off you go.
So have you found all models in Hugging Face to be vulnerable?
Oh, so this is like using rigging, which is our LM interaction framework. So right now we're doing agents. So similar to stuff like if you've seen like Crew AI and all that kind of thing, this is like our take on using agents, but we use them for offensive capabilities traditionally more than like other stuff. In terms of the vulnerable models, that's purely like Dyana, like more the blue team stuff. And I apologize if it wasn't clear. But what I would suggest is just keep an eye out, because on our platform soon, the aim is to like get like a bunch of profiled models and almost have like a leaderboard or something like that, and there'll be like a blog post and stuff. So yeah, like effectively, if we're gonna like scan a bunch of models that are hosting on Hugging Face, it's actually a task of mine to do. Yeah, again, like say, rigging has like a really nice chop. Oh, sorry.
Have you found that any of the online models will deny? Like you're asking it to hack into a system, using GPT-4, which things with, has
Yeah. Well. Oh. 1 sec. Yes. Some will. So I could observe like this, like literally, this is the code that I'm showing you right now, like the max history and the max pins on the system prompt, and you obviously saw the system prompts in the trace. Not saying like this, like GPT-4 is like more like susceptible than any other model, but that comes a case of actually, I'll touch about that a bit later in a minute when I kind of go into like our cyber evaluations framework. But normally you might just take like a bit of optimization, something like that. But not so much jailbreaks. Like a lot of it is like, like running the workflow, doing evaluations, and just like tuning. A lot of it is honestly like looking at data. I've never had to use a jailbreak so far. I mean, like in terms of like getting an agent to do the thing.
Like those jailbreaks where you just like talk like garbage text and just dump like 2,000 tokens into the context block. Like because it never worked with these.
I mean, they do work. It's an issue that like will never be fixed. Like Emmanuel is great with like prompt injection with jailbreak stuff, but it's a continuing pattern that is like prominent in models, and it's basically like a cat and mouse game, and will forever be. So like you'll find that a lot of times like a jailbreak works for a day, and then effectively like the model company which is hosting the model will just literally have like a classifier or like a block list, and they'll just block it. So like literally if you take the conversion, it's almost like thinking about like a static firewall, and like so yeah, hope I answered the question, but never.
You're not using the local model you used before, right?
Yeah, just using GPT-4. Like so this is the
But you know what I mean.
oh, sorry, I apologize. This was using Sonnet. This is using Sonnet 3.5, I believe it is, by looking at the database identifier.
You get the same prompt, just an A prompt before. I'm sorry, I can't do that. I guess it goes against the rule.
Yeah.
Do you see such docs in the wild with LLM agents?
I'm really sorry. Say that first bit again.
Do you see such attacks in the wild?
Oh, such attacks in the wild? Let me show you. Let me show you something really cool, like cooler. Yeah.
Obviously, as the goal to compete with, an LLM agent would be able to do massive damage unless defense would be proper. But the question is it already happening, or is it too early because the technology is constantly evolving and new?
Yeah, it is a really good question, and I hopefully will answer this by demonstration in a bit more time. Sorry, but what I can say is there is like a very valid point of when we're actually doing like, so part of Dreadnode, like our mission is like advancing the state of offensive security and machine learning, which is kind of like, if you're not familiar with the topic, is kind of vague, but effectively what we're doing is like we're pushing models to the limit, like when we're talking about like cyber evals. So like I'll go through our strikes platform in a second, but effectively like we're hosting a platform where we build a harness, which is like an environment, if anything, and then you're deploying an agent, and then you're evaluating that. And part of the thing, like what we do when we evaluate things, and if you'll see in other benchmarks, is a valid point, right? So like how difficult is it for like a traditional script kiddie or someone with like no domain expertise to literally like send a prompt to GPT-4 and it does the thing and it like launches some ransomware attack. It's very much something to be said, because obviously there's a trade-off of like, this is really cool doing this stuff, but if it's taking us like a week to do it when it takes me an hour to do it, then yeah. But obviously this is like a continuously maturing thing, and we believe like rigging is as our interaction framework between LLMs is like gives us that flexibility and great results. Yes, sir.
What was the decision between making your own framework with rigging as opposed to some of the existing frameworks that are out there? I know I've never new as well, so I might be part of your.
Good question, because it was there when I arrived. But I can tell you honestly, from experience, it is awesome. I feel like a lot of the ones I've interacted with, the functionality isn't there. A big thing for me personally is the XML tags. You'll also see, like, if you look at like Anthropic's prompting guide, they always recommend using XML tags. I think there's something to be said about that. So it's like one example of many interactions, but again, using things like Light LLM, we have access to a bunch of models. If like a model isn't available on Light LLM, we can create what in rigging we call it a generator, which is effectively it's just a model or a classifier, anything or a function that returns text. So we can like do custom models, things like that. Like our development team are like awesome. In fact, we have like hooks up to Logfire, things like that. I'll show that in an example in a second. We also have like a platform SDK, which like rigging interacts with in a great way.
The other way, just like the things, what you're saying sounds a lot like Pydantic or Kubernetes along those lines. Like existing frameworks. I was just wondering what there was a specific decision to roll your own versus.
Yeah, I mean, there's a bunch. I can honestly, like, hand on heart, tell you that if I didn't work at Dreadnode, I would probably still use rigging over others. It gives you like great abstraction. And it keeps you like really close to the inference layer, and it's also super easy to write the code as well. To be honest, like I know a lot of these are kind of like the same, but just from my personal opinion, yeah.
You said it's using Light LLM. That's actually running models, so self-hosted models, or is it mostly external models?
So with Light LLM, you can use self-hosted models, just like custom generators. Like we call it generator. It's just a model. So yeah, but like these examples, I'm just using like remote inference. Thank you. So what I will actually show now is, so when we talk about like hooking up models or agents, we need tools, right? Which is aka a function. We actually have a tool called RoboPages. There's kind of two parts to RoboPages. So you have RoboPages and the RoboPages CLI. RoboPages are individual YAML files which describe a function, aka a tool, to a model. They're like super easy, no code, and really simple to set up. We have like a concept of both offensive and defensive RoboPages. And then the RoboPages CLI server is a function calling tool server, which hosts the RoboPages. I hope that makes sense. So right here on the right-hand side, sorry, it's probably way too small. But on the right-hand side, you can see that I'm hosting a RoboPages server right now, and we have a bunch of RoboPages which are built. So RoboPages. So this is not an LM interaction framework. However, it is like a tool calling server, let's call it. So we have like a bunch of RoboPages in here. You can see like cyber, so let's say offensive, web exploitation, and like I'm sure like a lot of people are familiar with ZAP, for example. So this is like there's a really simple structured YAML file where we have a function which is built from a common. So all these are like traditional cybersecurity tools, and a function which takes like basic inputs like a name, description, and parameters. And effectively what it's doing is building like Docker containers locally on your machine, and then giving the agent the ability to execute functions within that Docker container. Yeah. So, sorry, there's a lot of switching between screens. So I tell you what, let me go through like an example of where I actually use rigging with RoboPages. So I'm using rigging as an LLM interaction framework, and I'm hooking it up to RoboPages, which is just like a bunch of like a suite of tools. There's a bit of code there where you can actually proxy this through Burp Suite as well, or like any proxy in like tool that you're running, whether it's Kaido or whatever else. I'm not going to do it because I'm already kind of like sick of switching between so many screens. But let me show you this here. So it's got like a very, just to give you an example of like what this code looks like. Honestly, this is like literally all the code. So I've got a system prompt of like enumerate all ports on TCP ports on 127.0.0.1 and provide a vulnerability report. I call it GPT-4 and I point it at my, I give it access. It's literally as simple as using this tools here, where I'm specifying the RoboPages server as a tool. So where did my terminal go?
What's served up by?
Huh?
What's actually served up by? Just like all the YAML files.
Yeah. So when you compile, this might be a bit easier visibly. So when you build the RoboPages CLI server, effectively what you're doing is, if you kind of remember, like where is it? This guy here, these functions are literally just here. So this is like basically the tool server. It's available yet. So I actually have like a standard out of this being called right now, but let me try. I seem to have lost my terminal, so let me try that again. Yeah. Oh shit! 1 second. I did do all this before, and then I knew this was going to happen. No. Cool. So again, like super close. I'll actually show you the log file as well. The idea of what we get with tracing with rigging. Effectively, I'm printing the whole what we call the chat pipeline here. So you can see that like 51 tools, so like 51 RoboPages are available. Each one of those RoboPages contains like multiple functions. If you don't see a tool, I do like highly encourage you to like throw up a PR. It's like super easy to create one. And you can see now, so if I go to, so we can see in this example that the model chose to use Nmap, which theoretically makes sense. It's probably the first thing that we would all go to. And the function that it called here is Nmap TCP port scan, which if this guy is oh shit. So literally the model is calling this function here. So we just provide this function like as a tool to the model to instruct it how to use said tool, right? And if I go to Logfire here, so I'm just using Logfire as an example, but we support tracing with like a bunch of them. You can see here that we can get things like the content, we can get like super close to the inference layer here. So see like all the inference layer, everything like that. Again, like you can see the model's output here, right? Sorry. Again, as you can see, the same thing in standard out, but it's also kind of nice in Logfire, and you can export this, etc. So what we're actually doing, the great thing here is that we're trying to like encourage and increase autonomy by giving the model access to all these different RoboPages. Of course, like the more you give it, maybe the more it will. I wouldn't say it would be overwhelmed. I'd say it's enhanced. So that was literally like a really simple Python script, which is just literally saying to the model, here is your task. Here is all the available tools. It'll always call Nmap when you do like port scan, because it's like that's like common in training data. But like if you think about what the point I'm hopefully trying to make here or get across is that how simple it'd be just to build like a multi-step workflow So your first step is like reconnaissance, which is like scan all your TCP maps, and then you go into like something like weaponization, which is then like building an exploit, and then you go into the next thing, which is like next step of it, like the unified kill chain, if that makes sense. Yeah.
I have a question.
Yeah.
So let's say you want the task to be to do a port scan of a big range instead of one host.
Yeah.
And the preferred tool would be to use something like mass scan so that it's more efficient. How would you use robo files or even maybe fine tune the model to get the model to choose mass scan over Nmap so that it's more efficient?
I think, to be honest, at this point, what I'm actually trying to do is increase the autonomy by giving the model the flexibility to. So part of like what I do in my job is like cyber evaluation. So it's evaluating like how common the model uses a certain tool, and then like how is that presented and how am I getting results, and can I like present that tool in a better way? Can I provide like ideally could I provide like a better function in the RoboPages server, and just kind of like optimizing that process. Obviously, one thing to be said as well is that theoretically, I've just like enumerated my local host, so I'm literally scanning myself. But also as well, like we're all security people here, like just kind of be careful with excessive agency. I don't encourage anyone to like point this at like an in production website and then start like scanning stuff, because effectively that's almost what you're doing. I know it's cool, but yeah. I apologize. I've been talking a lot as well, and I'm not like half as through as I was. Yeah.
So I just want to understand one thing. So the tool, does it spin up containers once it's decided the task is to be performed?
So
if you get responses and then they want like get initial access. So would it spin up one container, do the task, close it, spin up another?
yes, exactly that. So like hopefully this is probably a bit blurred. This is probably quite small, but what you can see here is that you can actually see. So this on the right hand side, what I'm showing is it's so dark in it. Oh, sorry, there you are. What I'm showing on the right hand side is I'm actually showing like so this is the server, like the RoboPages CLI server. And you can, this is like just like the web server logs. And you can see that it's actually like these are the calls that are actually being made. So like from what I showed you on the log file, that's like the inference layer. And then here I'm just literally, because I have it local, it's like I can show you it. You can see like the fact that it built the Nmap local and then executed it, and then you see like a post request to this same server because it's on localhost, right? Yeah. I take it questions are a good thing.
This tool which you have right now, is it a cloud-based tool for the customer, or
it's all local? All local. You could host it on infrastructure if you wanted to. There's nothing stopping you from it. But everything I'm showing you now is literally coming off my machine, off my laptop.
So it is not sending any data back to the.
No. All the code is open source. Obviously, the inference layer. So when you're actually sending so if I'm using like GPT-4, obviously there's a web request which is made to OpenAI's API, which is like it's saying like enumerate all ports on 127. But there's no. I haven't touched on platform yet. This is just like some of our open source tools which I've like built or participated in building. Just kind of like trying to show you guys some hopefully cool stuff, and just yeah.
So customer has to implement their own ChatGPT, right, in their infrastructure, or they have to use the ChatGPT from the
You could host a local model and do this. So you like if you were like super secret and you didn't want any like inference layer going remotely, you could host a local model, create a custom rigging generator, and then do all this like totally locally. Obviously, at some point though, right? You've got if you're like scanning a google.com, then obviously you're making an internet request. But you could totally sandbox this and isolate this if you wanted to.
Right. So they can have everything set up in their own tab.
Yeah. No, thank you. Sorry, there's some images in case anyone couldn't see the live stream. And just to get an example, like if you even wanted to get further, I shared like some code earlier, and you can like proxy this through Burp. So you can see, like, for example, here I was like scanning the Nmap Scan Me website, which is obviously intended for scanning. That's the whole point. And then you can see like the actual inference requests which are made to Sonnet in this case, right? And then obviously, yeah, you can see here like the Etsy password. Talking about Burp Suite, we also have a open source Burp app, which is called BurpFrence. You can blame me because it's a very bad name. But basically, it's an automated response capture. So what you can do is you can use remote models, or you can use local models. Effectively, what they're defined is, you see this llama chat.json. So you define just like a very simple JSON file, which defines like a model. So you can use Ollama, you can use OpenAI, Cohere, Anthropic. The idea of why I put Ollama in is because obviously, like, it can be very costly to like send a lot of tokens to inference providers. But effectively, what this does is you get like almost like a co-pilot kind of esque usage of a model when you're actually running through Burp Suite. So like effectively what the model does, it's fed the request and the response from each one, and then it's given like a system prompt, which you can also override or set like custom system prompts to look for like specific vulnerabilities and be like, hey, like, tell me what's up with this request and response pair. So it's almost like a kind of like a co-pilot hacking thing. Yeah, and also as well, like, it has a DB persistent storage, so like any findings like show up in like the traditional Burp Suite findings, and it'll store it to like a local DB on your machine. It's like, obviously it's way too estimated, but kind of get like that very similar request and response output. Again, that's available open source. Just literally download the Jython file, import it into Burp, and off you go. Also, as well, I put in a Open API scanner, so you can literally point the model at like an Open API schema or just a remote website and get it to do like a vulnerability report as well, right? And again, everything's like logged to the local Burp scanner. So talking about some shiny rocks, I guess, with AI agents. So one thing that you've kind of been looking at, which some of you might be familiar with, is code review. What time are we on, actually? We good for time?
We're about an hour in.
Anyone bored or not? That's a good thing. Okay. Yeah, so AI code review. So let me show you. So effectively what we did was just use rigging, create like a basic front end. And what we can do here, I'm not going to walk through this because it can take quite a while, but I will show you some examples. But just to like give you an idea of what this looks like, so you specify a rigging generator, amount of threads, times to run. You can actually scan a local directory, so that's like code on your, like, let's say you git clone something, or you can actually point it at a remote GitHub repository. Specify a temperature, specify guidance for the model, and you can also exclude files from analysis. And effectively what this will do is like kick off an agent, which will be fed like the code base, and then report vulnerabilities, which I will show here. So what you can see on the left-hand side is that web form, which I was just showing you. On the right-hand side, you've got a database of like findings, which are indexed by the model. The reason why I use a database is that it's like, obviously you just don't want like a load of unstructured output. It's really difficult. So like indexing it in something like a database is really nice, right? Yeah. Part of I guess like a couple of things to be said about this when we're talking about like the scaffolding that goes into this like agentic kind of framework is one thing, obviously, hallucinations and stuff like that, right? So one part of this is also part of like the multi-step agent workflow. Just added like a judge in here as well. So like a judge is fed the vulnerability and the piece of, and the abstracted code, and then produces like a second verdict on that. So we're getting like we're basically just narrowing down and filtering our results even further. And again, just like showing you some stuff from like this is like an open source repo which I scanned here, so nothing like super nuts. Effectively, this is like, I haven't done this because it does take a while to kick off, and obviously kind of time limited. But you can see from hopefully from this screenshot example, you can see that on the right hand side, I'm just providing a function again to the model, i.e. a tool, which I show it how to report and validate a finding. On the left hand side, you can see like it's literally scanning some source code and finding a vulnerability. In here, again, just kind of showing you like a stored cross-site scripting that we found as well, which is kind of cool. So basically, like, I don't know if a lot of people are familiar with like web application security, but that's kind of like where I started out. So yeah, sure, please, because I lost my train of thought. Yeah. Yeah, so sorry, I kind of skipped over the burp thing. I didn't show it just because we're like time sensitive, and I just wanted to kind of show like as much stuff as possible. But with the Burp Suite, with BurpFrence, we can put all the links to the tools. But yeah, like the idea is you can like hot load custom prompts and models, so you can like put a specific model which might be good for a specific thing, and then give it a specific system prompt, and then get it to like look at those request and response pairs. So if you're looking for like SRF in particular, or like IDOR or something like that, right? So yeah, you could. I hope that answers your question, but I think I'm pretty confident it would. Yeah. Yeah.
How do you find this compares to SaaS tools, like results-wise, in terms of like you got to judge so many fewer false positives, but have you compared it with like a Veracode or Sandboxing or something like that?
Yeah.
I'm curious to know the results. And then the other thing is, when I've seen other people try stuff like this in the past, the problem is the medium to large size code bases. Like feeding that into the model is problematic. Like it can't keep all of that in its memory while it's trying to process.
Yeah.
Does this work on?
Yeah. So that a very, very good call out. So part of like, if you're familiar with like, if anyone's like traditional, there's a lot of like code review. So when we talk about like taint analysis, you're like effectively looking for sources and sinks, like, right? That's how like a lot of these static analyzers work. So there's a lot of, like I said, there's a lot of scaffolding which put in, which kind of like almost mimic that behavior. So we like things where we have like a confidence level. One thing I actually didn't mention earlier is when we're actually doing like indexing all this in the database, we have like a third model, which is given a different kind of context and is, I think I called the function like is externally exploitable. So kind of like taking like a threat model and being like, okay, great, you got like, yeah, exactly, right? So that's what, hopefully that'll, yeah, give some context about that. So, but in terms of like SaaS scanners versus models, I can tell you the results are like the models crush it every time. Yeah. Again, I feel, and you do have a very valid point that obviously models have like a specific context length, right? So again, there's a lot of like tuning and scaffolding that goes into that. But I guess with like Google's dropping like 128 million parameters, like I feel like as the space is maturing, that's becoming less of a problem. There's also different ways to like approach this as well. If you're going to do like AST, like so you know how like Cursor and VS Code Copilot and all these things work, right? they all have like the different methodologies of like how much autonomy do you provide the model to like reach into the code base and find a function or something like that. So there's like different ways that you can cook up, which we definitely have done when kind of going through this as well. But yeah, results are good. Yeah.
What about integration of this in the sales sector compared to other tools? I won't say seamless, but it's possible, right?
I'm really sorry. Can you repeat that?
Integration of this tool with like in a SDLC lifecycle. Yeah. So is it possible? And if it is, how are the results presented? Right.
Oh, so I think like the question is, so like traditionally, like you put like a SaaS tool into like a CI/CD pipeline on like a GitHub action or something, right? Whereas like this is like theoretically this thing I'm showing right now is like a manual kickoff of like a Python script. Ideally, workflow should be continuous. Like we want to improve our benchmarks over time. Again, obviously there's a cost optimization to that. But there are tools that run in CI/CD pipelines and GitHub Actions and stuff now. Like, so at my previous tenure, the place I worked before, it wasn't the same, but I built like a GitHub app, which would like take a code base and then it would take the Git diff and then it would produce like a vulnerability report kind of deal, and then would like post a comment in GitHub and like, or like tag people or like deny the PR request and things like that. But I'm sure there are tools like this.
I was wondering about the one that you
Oh,
showed.
like the one that shows us like a research thing. It's not like it's not like a tool or offering or anything like that. Yeah. Yeah. So theoretically, just to keep it brief, scanned an open source repo from a target which does have in scope stuff as well as out of scope stuff. There's something to be said a lot about like coding patterns which might be performed in like open source and production. Able to find a vulnerability, manually exploit it, build the harness, verify if the model can exploit it as well. And then one actually cool thing we found with this stored XSS, which is in like this like a commerce kind of website, I think the terminology is, that this could be like this specific example, you could do it as like an unprivileged user, which you could then use to steal like a token of a privileged user to then escalate your own privileges. Part of, I don't know if it's going to load. If not, let me refresh it. Oh. Okay. Okay. I don't know why it's not showing it on slide, but also as well, if anyone's demonstrated with browser use, is a great tool where you can effectively hook up a vision model. So one of the things that like was difficult is getting a model to like handle session creds, especially if you've got like JWT tokens which are expiring like every 15 minutes. It's like really difficult to handle that. So one way that I kind of looked at, which you can see here, is like giving like a vision model prompts and like instructions and a task just to log into a website and store credentials, which you then use in the next step of the workflow, right? Also kind of cool. Browser use is great, not just for this kind of stuff, but so I hope we're okay for time, but our founders today did like a LinkedIn live stream and kind of demoed our new platform, which is like super cool and very exciting. We have a concept of what we call Strikes, which is our cyber evaluations platform. So if like building that harness of what I referred to earlier, kind of like this agentic workflow, where you can like write your own code, interact with our SDK. So if you use rigging or you use another library, I would use rigging. And then you can, the platform is a place where you can get like all this data You can also, it's also a great SDK for being able to grab data out as well. So rather than me just kind of talk about it, let's show you a quick, let me show you that. This is a product offering as well. So if anyone is legitimately interested, like from a company or anything, then please like just shout me in the end. What we have here is, I don't know if anyone, is anyone familiar with Dreadnode? First of all, I guess. Cool. Yeah. So we have a AI CTF platform called Crucible, which has like a bunch of machine learning offensive security challenges. So like a CTF platform, it's great. I'll go through it in a second. But effectively what I'm doing here is I have a piece of code called Callisto, which is like just an agent framework that uses rigging under the hood. And I'm actually pointing the rigging agent at our Crucible challenges. You can actually see here that all these challenges right here are challenges that are hosted in our platform. And this found flag here is indicating how many flags that the model is able to actually find in each individual challenge. So I think I kept my standard out here. There we go. Yeah, so again, this is all available in like tracing if you need to, but we can see here that there's a challenge called piece of cake. We can actually run it if anyone wants. Should we do it? Yeah. Cool. All right. So so we have a CTF challenge called piece of cake, which is literally by design. I called it piece of cake for a reason. It's a simple prompt injection, but just for the purpose of this demonstration, it's going to run it now. As long as it runs, cool. So you can see the model. So effectively, we spin up a container, which has got the notebook hosted locally. And effectively, what we're doing here is giving the agent access to a Jupyter kernel, where it's able. You can see there's actually a refusal there, but we're giving the model access. So when you interact with our Crucible platform, you're actually using. Here we go. When you interact with our Crucible platform, you're given access to notebooks. We hack through code. So like some of our challenges have like an LLM chatbot interface, but you can actually also use notebooks. So effectively what we're doing is we're giving the model access to a notebook, just the same as we would with like a human interaction here. And I'm running this with Sonnet 3.7, and you can see all our flags start with GAAAA, and you can see how quickly the model was able to like prompt inject. So this is like agents against like another large language model, which is like another piece of Python code, which is like prompted with not extracting the secret. And then if we go to here, this is our platform, like our commercial product. You can see here, last run that was completed. You can click into this guy. Here we go. You can see that the model took 4 turns in this case. So in each step here, we can get extremely close to the inference layer, get a bunch of information about the task that the model was called. And in here, you see that the model was able to successfully gather the flag. Where is it? Which is here. So.
Does that view also provide insight into the reasoning of the model, so you can potentially see
if you use a reasoning model, yes, absolutely. I've used like DeepSeek against this as well, and like pretty good, pretty cool results. Again, this is literally just like, so Callisto is like effectively a Python script which is using rigging to give an agent access to a Jupyter kernel and these challenges and API structure and stuff. So yeah, like absolutely, you can. We have like a very flexible SDK where you can include things like tags and labels, which you can like easily display on the UI and stuff.
Alright, is it just ML-based CPS that you model creating and find that you also find that I guess?
Well, again,
based on cryptography and
so I've lightly tested against web apps so far, but like the Bandit example was just like a network CTF. So in answer to the question, yes. Pardon? Yeah, again, it's just like how you direct the agent and what tools you give it access to complete the CTF. But yeah, there's no limit. I'm showing like AI CTF here because this is like actually, this model is actually reaching out to our Crucible platform. So we're like, yeah.
Like crazy about, is it possible to replace traditional time vectors with some of the scaffolding you've shown here? Like point this out a lot about and just
I mean, there's, I don't think we're there yet, but we, like, for example, like this, in comparison, we could get a human to see how many turns they would take to solve the piece of cake challenge, given like the prompt and everything that the model's done. You can kind of get a benchmark. It's really difficult to like give the model access to a web app and be like, find every single vulnerability on this. Like I was kind of, I apologize because I lost my speaker notes because I'm sharing, but like the point I was talking about of agents is like very like structured inputs, the flexibility of rigging, and then giving like isolated defined tasks and like building that workflow of each individual task is like is definitely the most successful that we've seen. But there's a bunch of companies as well, right, who are kind of already like starting to do that. So like, yeah, it's definitely a space which is like automated AI pen testing is kind of the thing. Yeah. Thanks. Again, like I said, oh my God, that's really bad. But the SDK has like is fantastic. It's really flexible. It's really great at being able to get data out. So what you can kind of see on the right hand side, or what you actually can't see, is just like a heat map that I just created in a notebook, where it's evaluating, I think it's like GPT 3.5 against every single one of our challenges, and you can get like metrics and insights into basically how the code you write, so how many steps the model took, what temperature it was run at, how many times it gave up, how many times it refused, things like that, and then you can obviously use that to compare and evaluate benchmarks against different models. I won't go into it, but also as well, if anyone is interested, please let me know. But we have a awesome tool called Spyglass, which is an AI red teaming tool. So when we talk about like attacking models, we also have a great tool where you can effectively like try and exploit vulnerabilities in an remote inference endpoint. We use a concept of like a series of prompts or data sets. You can get a data set out of Spyglass run, and then you can actually use that for fine tuning as well. So it's like part of that whole model development lifecycle process of protecting models. One thing, again, I kind of mentioned it earlier, Crucible, I would suggest you check it out. It's really cool. We have like almost 70 challenges right now, where we deploy a new challenge every week. They like cover a wide array of AI vulnerability, system exploitation, prompt injection, data analysis. It's a great place to get started. It's free. You can also download your own data now, which is a really cool new feature. So whether you, like when you're writing your own code, you just define like a tagger or like a custom header, and then you can use that to like export your own data sets from Crucible, so you can see all your own requests and everything that's sent to the challenge platform. But yeah, highly suggest check it out. It's really cool. Also as well, a couple of weeks ago we launched a Dyana challenge, which try and integrate all our products into one. So there's actually like a CTF challenge where you have to use Dyana to profile a backdoor model and get the flag. Really cool as well. We also launched today Offensive AI Con. So just check out the web link. It's in San Diego in October this year, and it's the first offensive like AI cybersecurity conference, which we're proud to be hosting alongside some other partners as well. Yes, sir.
Is it virtual too?
Good question. I don't think so. I would say no. I'd say be there or be square. And with that, thank God I'm done. offensiveaicon.com. Sorry, I should have given a QR code for that as well. But yeah, so thank you everyone for coming to here. Thank you.
Any last questions for us?
Yeah, does anyone have any other questions? Yeah.
All right. Well, thank you all for coming. Thank you again to Team Code Cybersecurity. I don't know if there's any piece still on. No?
Probably not.
Well, thank you for coming, and hope to see you at
Thanks. Thanks.